In this video, we will start with the concept of vectors. Our focus will be 2D vectors and the relation of vectors with coordinate geometry. Let's get started with the basic idea. We know that a coordinate such as xy can be written as a column vector. How do we write a column vector? We write x at the top, y at the bottom, and we write it inside a bracket. This format is known as a column vector, which means that a point 3, 4 can be written as 3, 4 like this. This is the format of coordinate geometry. This is the format of column vector. Now let's draw a point on the Cartesian plane. The x-axis and the y-axis is known as the Cartesian plane. So this is the x-axis and we have the y-axis. Let me mark the origin 0, 0, and I'll mark a point Q over here. The coordinates of Q are A, B. That means if I draw a line starting from origin all the way till Q, what I can do is that I can draw a triangle. So I am drawing a vertical and this is the horizontal of this triangle. The distance from origin till this point is A. Why? Because the x coordinate is A. Similarly, the distance from the x-axis all the way till this point is B because the y coordinate is B. So therefore, A is the base of this right angle triangle. Why? Because a line is parallel to y-axis, this particular line. A line is on the x-axis, this particular line. Therefore, this angle is 90 degrees. So therefore, the base of this triangle is A. Similarly, the height of this triangle is B. And let me label this as D, which is the hypotenuse because this is opposite the 90-degree angle. Now, can we apply Pythagoras theorem over here? Yes, we can. Square of the longest side, which is the hypotenuse, is sum of squares of the base and the height. So this is the base squared, this is the height squared. In other words, if I make D the subject, I'll add square of the base to square of the height. After adding it up, I'll take the square root. So this is application of Pythagoras theorem. Now let's apply this to a particular question. Let me draw the grid once again. So this is the x-axis, this is the y-axis, and I'm labeling the origin as O and the x-axis and the y-axis, and let me label a point 1, 2, 3 and 1, 2, 3 and 4. And this particular point, let's call it S. The coordinates of S are 3, 4. I'm drawing a straight line from origin all the way till S. So now I can see that the height of this right angle triangle is 4 units. That's the y coordinate. And the base of this right angle triangle is 3 units. That is the x coordinate. So therefore, this distance from origin till this point, d square, is equals to 3 square plus 4 square. This adds up to 9 plus 16, which becomes 25. Therefore, d is square root of 25, which comes out to be 5 units. That is the length of this line, which is OS, which is the distance from origin till this point S. Now, let's relate coordinate with column vector. We know that xy can be written as x and y this way. This is a coordinate and this is a column vector. Now, a point such as S3 3, 4 can be written as a vector OS as 3, 4. This is again the coordinate. This is a column vector. A vector with respect to origin is known as a position vector. Let's look at the diagram once again. We know that if I have to walk from O all the way till S, that is this vector OS, I have to walk 3 units along the x-axis, and then I have to walk up 4 units along the y-axis. That's how I'll start from O and reach S. So this is the position vector. Let me label it with an arrow, which also means that the magnitude of this vector should be the same thing as distance from origin till this point S. So let me write it down. So distance from origin to point S is exactly the same thing as magnitude. This is the symbol for magnitude of the vector OS. We know that OS is 3, 4. So magnitude of vector OS is simply 3 square plus 4 square, add it all up and then take the square root. This is 9, this is 16, add it up, take the square root, which is square root of 25, which comes out to be 5 units. This is the same answer that we obtained earlier as the distance between the points O and S. So in general, we can write that if a vector OP is given as xy, therefore magnitude of vector OP is simply application of Pythagoras theorem, which is x square plus y square, and then take the square root. Now let's move to the distance formula. The distance formula is used to find distance between 2 points. Let me label one point as A. The coordinates are x1 and y1. The other point as B, x2 and y2. And yes, there is a comma in between the two. Now I am writing down the distance formula, which is distance between 2 points, which is x2 minus x1 whole square, y2 minus y1 whole square, add it up and then take the square root. We should also know that distance between 2 points is the same thing as length of line segment. That is a piece of the line. Length of line segment AB. Now let's apply this knowledge with vectors. Let's say there is a point A, the coordinates are 1, 2. There is a point B, the coordinates are 7, 10. And let me write A as OA, which is 1 and 2 in the column vector form, and B as OB, the position vector of B, as 7, 10. Now I need to find the distance between these 2 points, or I need to find the vector AB, and then I need to find the magnitude of vector AB. Now let's first draw a diagram. Let me label these points. So we have the y-axis and then we have the x-axis, and then we can start labeling the origin and points 1, 2, 3, 4, 5, 6, 7 and 8 along the x-axis, and similarly along the y-axis we have 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Now the first point is A, which is 1, 2. So this is the point A, 1, 2. And then the other point is B, which is 7, 10. So this is 7 and this is 10 over here. Now I want to go from A till B. So I'm drawing this green line like this. Now let me count the squares. So this is 1 and 2 and 3 and 4 and 5 and 6 this way. And then 1, 2, 3, 4, 5, 6, 7 and 8. That means by looking at the diagram, I know that the vector AB is 6 right and 8 up, which gives us the column vector 6, 8. Now, can we find it some other way? The answer is yes. Let's focus on the diagram. I'm starting from O, I'm going till A. From A, I'm going all the way till B. So the shortcut, the shortest distance is going from O till B. So therefore, what I can say is that let's start from O, let's go all the way till A. Then from A, let's go towards B. The starting point is O, the ending point is B. So this equation you form using the concept of addition of vectors. Now, we know that OA is basically a coordinate turned into a position vector. So we know that A is 1, 2. Therefore, OA is simply 1 and 2. And similarly, B is 7, 10. I can write this thing as OB as 7 and 10. So OA plus AB equals to OB. And I'm putting on all the arrowheads. So therefore, AB is OB minus OA. What is OB? That is 7, 10. And what is OA? That is 1, 2. And then when we do the subtraction, 7 minus 1, this comes out to be 6. And 10 minus 2, this comes out to be 8. That is exactly what we have obtained from the diagram. Let's double check. 1, 2, 3, 4, 5, 6. And then upwards 1, 2, 3, 4, 5, 6, 7, 8, which is written right over here. So that's how we can obtain the vector AB. Remember the shortcut, that is position vector of second alphabet. So this is the second alphabet or the second letter minus position vector of the first letter, which is OA. So remember, it's second letter minus the first letter. For example, in any other case, if it's QR and we are interested in QR and we have the coordinates of Q, we have the coordinates of R, that will be OR minus OQ. Why? Because OR is the position vector of second letter, OQ is the position vector of first letter. Now we can also find the magnitude of this vector AB. So AB is 6 and 8. Therefore, magnitude of this vector AB is 6 square plus 8 square, the whole thing added up, and then the square root is taken. 6 square is 36, 8 square is 64, 36 plus 64 adds up to 100, square root of 100 comes out to be 10 units. That is the magnitude of this vector. One last thing in this particular video, that is, we write X and Y, and X coordinate is denoted by the symbol I, Y is denoted by the symbol J. That means a point P written as X, Y can be written in the column vector form as OP, which is XY. It can also be written in the IJ notation, which is XI plus YJ. So let's look at some examples. If I have a point such as C, whose coordinates are -3, 7, I have point D, which is 5 and -2. I can write OC, the position vector, as -3 and 7. I can even write this thing as -3i plus 7j. Similarly, OD, the position vector of D, will be written as 5 and -2 in the column vector form, or 5i minus 2j in the ij form. So what have we learned in this particular video? We learned the basics of vectors in relation to coordinate geometry. CG stands for coordinate geometry. We talked about distances, the distance from origin to a point that can be found using the distance formula from coordinate geometry. It can also be found by finding the magnitude of the vector OP. Similarly, the distance between 2 points A and B, which is also the length of the line segment, it's also the magnitude of the vector AB. And last but not the least, we wrote a vector in the IJ form also.